We are recording. Good. Now, this is where we left off last time, just as a quick review. Imagine we had some function here called square of sum, AB. Okay? This is how Python works when you call this function. So this function is defined somewhere. And it exists, so Python's happy. So if I call this function with like square of sum 2, 3, Python handles the execution like this. First, it'll see, like, do I know if this function exists? Yes, it does exist. And then Python will jump to that function and start to execute the code in this function. But when I called this function, I gave it the arguments 2, 3. That means that the value 2 and 3 will be assigned to the respective parameters A and B. Effectively, it's like you wrote this line of code. A equals 2, B equals 3. It's effectively that. You are assigning values to these parameters. And a parameter is just a fancy variable. All right? By the way, as a note, just in general going forward in this lab, careful about food and whatnot. All right? There's very few computer labs on campus, and this one is actually like controlled by the CS department, and there's crumbs in here, there's going to be no more food in here again, okay? Wrappers and garbage, there's going to be no more food in here again, okay? So just be wary of that. All right, so how would this work? Well, it would take A and B, which are 2 and 3, add them together, so that's 5, and then it says 5 times, well, it's 25, puts it into D, returns D, okay? What does that return? Well, that's how we get information out of the function. We pass information to a function through the argument's parameters. The function does its thing, and then a value can be returned by the function via the return statement at the end. It's often at the end. It doesn't have to be at the end. If you provide too few arguments, see, I say parameters here. Really, I mean arguments. Python will say, like, you're missing one. If you give too many, it'll be like, you gave me 3, I needed 2. So Python will be helpful if you're calling it wrong with the wrong number of arguments. And return. Every function you call returns a value, whether you like it or not. Whether you actually write return, it returns a value. But we covered this in lab last week, right? So notice that we wrote return. This one returns a value. What are we returning? The value D. So here, it's like this. I need a volunteer. You're going to be my volunteer. You're the function square of sum. I give you 2, 3. You do all the number crunching. And now you have the number 5. Go like this. You've got 5 sitting in your hand. Throw it back at me. Great. I got it now. So I called him and I gave him the values. He gave me back something. The number, what did I say? I meant 25. 25. This is 25, right? So now I've got the number 25 back, and I can do whatever the hell I want with it. Like here, with Celsius to Fahrenheit, I gave it 20. The function will go and do all the number crunching, and it finishes with the value 68 in this case. The value 68 is returned, meaning when I call this function, Python goes to and jumps to that function, execute all that stuff, and when it's done, it wants to return the value 68. Python will then return to the line of code that it was called, and right here, Celsius to Fahrenheit effectively evaluates to the value 68. We store the value 68 in temperature, we print out temperature. So return is a way for a function to like give a value back. This means go calculate this and give me back the value, and I'm going to put it in temperature. That's how it's happening. That's what return does. And then here I'm printing out the temperature. If you do not write your own return, Python sneakily adds one for you. You'll never see it, but it will add one for you. It adds a line in that says return none. You'll never see it, but it's there. If you don't write your own return, it adds return none. Every function needs to return something. And what's interesting about none, like we talked about in lab, none is a very special value. In fact, it's its own type too. We have integers, we have strings, we have floats, we have booleans, which we'll learn about more shortly. None is a value. It's a very special value that means nothing. It's something that has a meaning, like it symbolizes nothing. Because when you have no information, it can be ambiguous. But if you have something that, oh, when I have this, that means I have nothing, that's a little bit more concrete. I know it sounds funny, but this will kind of work its way out in your head as we go. It's a very important concept going forward. Now, we did this in lab effectively, but I will do it again right now real quickly. We'll do it together just to reemphasize what we talked about in lab. So this activity, so I have this here, and then if I go down here and do temp equals Celsius to Fahrenheit, 66, print temp. I get 150.8. I guess that's what 66 degrees Celsius is. Cool, in Fahrenheit. So I run this, what happened? So Python goes like this. Oh, great, this function exists. All right, whatever. Oh, Celsius to Fahrenheit 66. Jump up to here. Temp in Celsius takes the value 66. We do all the number crunching. This evaluates to 150.8, I guess. It gets returned. So Python then jumps back down to here. And the reason it jumps back down to here is not because this is the following line. That's just a coincidence. It jumps back down to here, and Celsius to Fahrenheit 66 effectively turns into the number 150.8, which gets stored in temp. We print out temp. Okay? Any questions about that? That's the normal execution. If I go here, I'm going to write a slightly different one. Print. But instead of return, I do print. Oh my goodness. All right. So here, let me hit run again here. This can re-emphasize something slightly. So I'm calling Celsius to Fahrenheit. I'm not calling this function. Python will go, okay, great, this function exists. Great, this function exists. Oh, jump to Celsius to Fahrenheit 66. Do everything. That's 150.8. We return to the calling line, which was this. 150.8 goes in temp, print out temp, which is 150.8. Okay? Now if I go here and I say print, and I do it, we see something like this, which is funny. Why did we see this? Well, we see this because we called print Celsius to Fahrenheit. Let's follow the code. Here's one of the tricks. There are very few tricks with programming about like making it make sense. Here's one of the tricks, and I know this is going to sound obvious, but you'd be surprised by how much people kind of miss this point. Like, why does it do that? Well, what does the code say? The code is going to do exactly what you tell it to, so just follow the code. So, okay, great, this function exists. Great, this function exists. Oh, we're calling a function which one? Well, not this one now. Print Celsius to Fahrenheit 66. So we jump up to here. Temp in Celsius 66. We do all the number crunching. Temp in Fahrenheit will be 150.8. And what do? We print it out. Line 9 says print. That's the line that printed out 150.8. Not this print. This print. Okay? But then what is this none? Well, print Celsius to Fahrenheit. We never wrote a return. So Python went and it sneaked this line of code in. You'll never see it, but it added this line of code. Return none. In fact, you'll even notice that none kind of turns blue. That's because it's like a special value for Python. So Python added this. It returned this special value that means nothing, and it's called none. So when we print, so this gets returned, print Celsius to Fahrenheit, turns into none. None gets assigned to temp. We print out temp, it's none. That's where we see that. Okay? I talked about this in lab. In general, never, ever, 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 ever put prints inside of your functions. If you do it, the police ain't coming for you. It's fine, but you really are creating more potential problems for yourself. And if you say, and I say this last time, if you say, well, no, what if I really want my function to print something out? Don't. Return it, then print it out later. You want all of your prints to be like at the top level. And when I say top level, I don't mean up here. I mean most this way, most unindented. You want all of your input-output stuff to be here. Your function should be nice, clean units that just don't have side effects, avoid having side effects. A print is a side effect, right? Because like, going back to that example where I gave him 2 values and he gave me back a value, a side effect would be like, so I'm the computer talking to a different part of like the computer kind of when doing a function. A side effect would be like, he yells to everyone in the room, 25, that would be like printing it out, and then he gives me back nothing. Like, that's like a side effect. don't worry too much about that. Anyways, the point is, if I don't write a return, Python adds this for you whether you like it or not. So that's why we see none. In Colab, this can lead to quite a bit of confusion, but don't worry, there's a trick to never falling to this mistake. The reason this can cause confusion is, if I do, like, look, I'm going to run this code, okay? Print Celsius to Fahrenheit 66, I see 150.8. Now you might ask, where'd the none go? Well, it returned none, but I didn't do anything with it, so Python was like, whatever, just none, it doesn't matter, okay? Right? The reason this can be confusing is if I do this, it looks as if it's giving you the exact same output. So you may foolishly think, oh, return is like print. Absolutely not. This is Colab pretending it kind of is, but 150.8 was a value that never went anywhere. It's this dangling value. And when you have a dangling value on that last line of code, Python, like Colab, just shows it to you. And that's what we're seeing here. The code never printed anything out. Colab just kind of tricked you into it. Now, this is something to watch out for, but as the simplest rule possible to never fall for this mistake, never put prints in your functions. If you really want to print something out, print it out somewhere else. Like that return then print. The other half of the rule is, if you want to print something out, use the print word, use the print function. Don't ever rely on, like there's no print here. There's no print, but yet it showed me something. Bad. This is very bad. Don't do this. In fact, if I were to take this code and copy and paste it into like the environment that the marker is going to use, this code produces no output because you never printed anything. It's just Colab tricking you. Long story short, if you want to print something out, print it out. But don't do it in a function. Do it outside of the function. Like this. Do you see what I mean where it's like don't do it in the function, do it outside. If you want this function to really print something out, don't do it, return it. Then if you want to print it out, then do whatever you want with it later. But as long as you're doing it out here and not in the function, you're in great shape. The Python police aren't going to come for you, but the marker will. Okay? Any questions about that? Because now is the time to ask. I would say this is probably one of the early things in the semester that students get hung up on. The trick is don't think too hard about it. If you want to print something out, write print. But don't put it in a function. Yeah?
I was like copying like what you were putting and I got like a few name errors. I don't know if like I just wrote something wrong.
Let me have a quick look because sometimes it's good to see these types of errors because other people might find them too. Let's see. Temp in Celsius. Where's your... because you don't have a function called temp in Celsius. You have a function called Celsius to Fahrenheit and print Celsius to Fahrenheit.
Oh, okay.
Yeah,
so
that's
do
why.
I just like where
You
would
just-
I put it in like?
So where is name? Line 7. Temp in... Oh, you just missed that and that.
Oh.
That's all. It was just a type. Sometimes when you see like a name error and you're like, but it's right there, just triple check your spelling. And I know it sounds like duh, but it's very easy to mix those things up. Also a funny thing, be wary about like the values L, uppercase, actually it's not too bad here, and 1. In some fonts, these symbols look very, very, very similar, which can create problems. I'm speaking from experience, so just be careful. What else? When you called me over, I thought of something else I wanted to mention. Now I can't remember what it was. Name error. Well, hopefully it'll come back to me. All right. Other questions, though? That was a good one. Name errors, watch out for them, but just triple check your spelling. All right. All right. Warning. Yeah, this is the warning I just gave you. All right, here's an activity. Write a function called Euclidean distance. x1, it takes 4 parameters, or it has 4 parameters, and it calculates and returns the Euclidean distance between 2 points. And if you don't remember how to do Euclidean distance, that's it right there. So quickly do that function. I'll give you a few minutes to do it, and then we'll do it together, and then we'll carry on. Raise your hand if you're done. Raise your hand if you'll be done in like 1 more minute. Okay, take the minute. You're good. What's up?
So my friend showed me that he made this code in Python that generates fake phone numbers.
Okay.
And I'm desperately trying to figure out how the heck he did it. And every time I run this, it says no module named that.
From Faker. Oh, you'd have to have something called Faker. So from Faker, I'm guessing Faker isn't in the standard library. So go here, just hit plus and type Python Faker. There you go. I'm guessing this is not part of the standard library.
Probably not.
So you would have to like download this to your computer. Now it's rather easy to do. In fact, what is this here? Is this VS Code?
Yeah.
I wouldn't be surprised if VS, here, can I steal you for a sec? I'm willing to bet if I do this. So some IDEs would be like, you don't have this. Do you want to download it? And you say yes, and it would add it. But this is it looks like it depends. It has a dependency. Yeah, pip install Faker. This is how you would get it.
Okay.
And then it would work. Don't worry about it too much. But if you want to see how they did it, I don't know, read this documentation. It'll probably tell you exactly how they did it.
Okay.
All right. And then is it the sum? Yeah. Well, the distance should be 2. What am I doing wrong?
You're not reading it.
Yeah, I am.
Oh, you did. What should it be for your numbers? 2.
Shouldn't it be the distance? Oh, no, 2, 2. I meant, no, that makes sense. 2. There we go. No, I was wrong. Not Python. Don't worry. All right, here's how I did it. I did it in multiple lines of code because whatever. If you did it in 1 line of code, more power to you. It's entirely fine. I just did it this way. I did the x difference squared, y difference squared. Then I did the math square root of this. Now, what is going up with this? Well, I talked about this in lab, but I'll say it again. Python includes the standard library. Every programming language has what they call the standard library, which is a suite of like a bajillion different functions that are commonly used. So you don't have to reinvent the wheel. That's fantastic. Who here wants to go write the function to calculate the square root of something? I don't. So I'm glad Python gives it to me for free. However, unlike a lot of functions like print, for example, or type, those functions, like there's a lot of functions in the standard library. And if Python were to load all those functions up into RAM, that would take a while and it wastes a lot of resources. So Python actually tries to load up a minimal set of its standard library when you turn it on. Like print and absolute value and type, they're there for free. But if you want to do square root, that's fine, but you have to say, okay, go import the math chunk of the standard library. And that's where all like the mathy stuff exists. And if you were to say, how was I supposed to know that? You go Python square root. And you go, oh, look, it tells me import math. Oh, great. Okay, cool. Look, even like the Gemini told you exactly how to do it. Perfect. Great. That's how you would have figured it out. No programmer has the full standard library memorized and where every library, blah, 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 blah. Math is called like a library. It's where all the math stuff is. Who decided what goes in the math library? Probably Guido. So here we are. Don't worry, you would not have been expected to have memorized this. No one would be expected to memorize this. Obviously, I remember where it is just because I've done it a bunch. But up until now, how many times have you coded with Python and how many times have you needed the square root function? Probably a pretty big difference between the two. So if you really need it, you load it up. Great. So that's why I have this math.square root and then the different squares added together return distance. This is just me going out of my way to make this function longer. Again, it would have been entirely reasonable to have this on one big line because, like, in fact, I almost find this code less clear. Like, okay, great. It's in a function called Euclidean distance, meaning if I call the function Euclidean distance, it's probably calculating the Euclidean distance. It's a good function name. But you want your code to be clear. And when I look at this, like, okay, you know, it's not unclear, but I'm willing to bet if you saw code where it was on one line that looked more like this, your average human who's writing code would probably be like, oh, that's Euclidean distance, right? So don't worry too much about how I wrote it. Did anyone by chance, though, not import math and instead did this? Did anyone do that? Well done. Good job. If you're like, what? The square root is the same as putting something to the power of 1/2. So you could actually do this without having to import math. However, I could make the argument that math.square root is more clear. So whatever, we can have arguments about what's better code or not, but the point is you could actually have done this by just raising it to the power of 1/2, which is pretty neat. All right, and I don't have the best variable name here, but whatever. Any questions about this one? All right. So execution flow, this is how Python would work. We talked about this already, but let's do it again. Python, when we hit run, Python would go, okay, yeah, great, that exists, great, okay, cool, yep, great. Oh, line 6, finally something. Celsius is 24, got it. Fahrenheit equals, oh, okay, go call this function Celsius to Fahrenheit with the value of Celsius. So it jumps up here, temp in Celsius will take on the value 24 because that's what Celsius is. It does all the number crunching, it converts it to some value, it gets returned and is stored in Fahrenheit, we print Fahrenheit. Python goes to line 9, nothing there, and then it goes, oh, okay, now Celsius is 32. Okay, call Celsius to Fahrenheit, we jump back up here, but this time it's 32, we do all the number crunching, it returns a value that gets stored into Fahrenheit, we print it out. So with this style with functions, you'll see that Python isn't, like it's running one line at a time, but it's not necessarily from 0 to whatever, or line 1 to whatever. It's going to be jumping around, but it jumps around in a systematic, easy to follow way. Yes?
I got another like error for the, what is it?
No, that's inside the function because you have an indent.
Oh yeah, watch, you got a sneaky little space there. If you want it indented, press tab.
Tab?
Yeah. There. And do you want the other things to not be indented? No, it looks like you don't want that indented because it's not part of the function. Oh wait. Yeah, you probably want to have that return here.
Okay.
So move that there. Yeah, put that return in here. Just copy paste it there and then hit run. It should work. But make sure it's indented. All right, great. All right. Now, we're not going to do this because we talked about this example multiple times before. But remember how we talked about abstraction. Functions are a great way to facilitate abstraction. Instead of writing all that code out to convert Celsius to Fahrenheit or the Euclidean distance or whatever, you can have a function that just does it for you. In the same way that it's much easier, like look, I could say, look, like imagine telling someone, explaining to someone how to cook pasta with these instructions, right? Like you could do it. But humans operate at a much higher level of abstraction. So you would say something like, grab a pot, add water, let it boil, add a little salt, put your pasta in, wait 10 minutes, you're good, right? Like we operate at a higher level of abstraction. And functions allow us, they facilitate abstraction really well. If I've got all these complex steps, well, if I could turn all these complex steps into one function call that has a good name, that's really nice, right? All right. Okay. So yeah, we could do that, but we would create instructions or recipes or whatever, algorithms, at two very different levels of abstraction. Will both do the same thing, but they're at different levels of abstraction. And one would be much more simpler than the other. All right. Using abstraction, you've been making use of print a lot. If you were to go and open up the print function, there'd be a lot of crazy crap in there. And I'm glad I don't have to write that code. Fortunately, I have a function I call print. It just prints stuff out for me. It's fantastic. I don't need to write it. Print is an amazing example of abstraction. But we can create abstraction by writing functions. There's other things we could do to create abstraction as well. So without being able to recognize, like we can organize our code into like levels or layers of abstraction, writing complex software becomes prohibitively difficult. If we don't have the ability to create abstraction, like write functions, it becomes way too hard. And that's how we live our everyday life too. This isn't a programming thing. This is just how we interface with our world. Like, again, when you're driving a car, are you thinking about pistons firing? Probably not. You don't need to. It doesn't matter. You don't interface with your car at the level of pistons firing. You interface with it with a steering wheel, okay? And you are, yeah, like I said, you're already experts at this at real life. However, it's really not just that simple to just start creating abstraction in code. This is a skill you develop over time. It's more of an art than a science. Yeah, there's systematic ways we go about doing it, but this is a skill you develop over time. No one expects you to be a pro at this overnight. And learning and knowing when and how to create layers of abstraction requires a really deep understanding of what you're doing and the problem you want to solve. I really want to emphasize this at this stage, especially because I feel like I've been putting an emphasis on like writing good code. Okay, great. You always want to write good code, but don't let writing good code get in the way of, like, always try to write good code, but don't let that stop you from writing code, right? Don't let, is this the best way to solve this problem? Is this code good quality code and whatnot? Don't let that stop you from actually writing the code to solve the problem. Okay? All right? It's important not to get too distracted by that. At this stage, it's probably not going to be a problem, but I do want to emphasize it because I have also been emphasizing write good code. So what do I have in this warning? I got to emphasize when and where to create layers of abstraction is difficult to recognize. It's not something you're going to learn by reading about it. You're only going to learn by doing, by getting a feel. And every situation is nuanced and different, right? So you're not going to be a pro overnight. Often there isn't even a right way to do it. There are better ways and less good ways, but there isn't a better way, a best way. That might even be a foolish question to ask. The point is, however, no one is expecting you to be experts at this stage, so don't let that stop you from going and solving your code or your problem with code. Now, okay, I showed you a bunch of examples of functions. Now let's take a step back and generalize and give you the general idea of a function. This is what a function looks like typically in Python. Def function name, that's the name of the function. Def is a keyword. Function name, that's whatever we want. It doesn't have to be called function name. You could call it function name. Probably not a good name, but you want to give it a good name. And then you have what we call the formal or the parameter list. Basically, however many parameters you want. This like you could have like as many as you want. Okay? We saw some examples where we had none, we had 1, 2, 4. You can have as many as you want, but like this is the general idea. Followed by however many statements you want. And at the end, you may or may not have a return, though Python will add one for you. That's the general idea. The colon here, very important, otherwise Python will yell at you. And the indentation, very important. All the code in your function that you want in your function has to be indented. This code here is a part of the function. This code here is not part of the function. That's it. Some languages use different syntax. Some languages will use something like this, like these braces, to kind of like show where it is. Python uses white space. A lot of programmers have strong feelings about that. Yeah, and that's it, right? Cool. Okay, we did this in lab, so I'm going to skip over it for the sake of time. Or I'm going to do it together for the sake of time. I have write a function called concatenate strings that takes two strings and returns the concatenation of those strings. Great. So let's go down here. Def AB. I'm calling them AB. Maybe I should call it string 1, string 2, but I'm lazy. A plus B. Great. So let's test it. Equals concat strings, hello, world, and then print result. Great. Nothing about this should have been particularly shocking, but let's cover it just in case. Def concat string, so define, it tells Python we're defining a function. Concat string, that's the name of the function. These are the parameters, colon, indent. It's a very simple function. All it does is return the sum. I suppose it's not really a sum, but it's like the plus of these strings, which means concatenate. So when we call it down here, we call concat strings hello world. It takes hello world, concatenates them, and returns the result into result. We print it out. If you ask yourself, how come it didn't add a space? Well, there's no space in here to concatenate with. If you really want a space, you could do something like this. I don't know. There, right? But that only worked because it's the string hello followed by the string space world. It just does it. There's no spaces. Cool. Any questions about that? Because this is important to understand. Okay, now, we covered this in lab with the this is tough, but we're going to do it slightly different here with strings. It's the exact same idea. When I made them a moment ago when I was talking about that print return stuff where it causes confusion for students, that's more of like a programmatical confusion thing. This right here is probably the first very difficult, this is probably the first real challenge I'm throwing at you. That's not to say everything before should have been trivial. No. But what I'm requiring you to do is use abstraction. But it might not be natural to you immediately. So this is probably the first like tough problem. The other issues we've been having have been like Python-y issues. This is more of a programmatical issue where it becomes tricky. So this is where things get tricky. If I show you this and you're like, yeah, makes perfect sense. Awesome. That's great. But if I show you, like if we work through the next activity and you find it's rather tricky, that's normal because it is tricky. So what is the question? Write a function called crisscross concatenation that will take 4 strings and return the concatenation of the first, third, second, and fourth in that order. But we are not allowed to use directly this plus to concatenate the strings. All right? Now, first thing I'm going to do is I'm going to do exactly what it tells me not to do. So I'm going to do crisscross, def crisscross concatenation, A, B, C, D. Oh, I remember what I was going to show you before too, but we'll come back to that. Return, hold on, let's do like S1 equals A plus C, S2 equals B plus D, and then S3 equals S1 plus S2. I could do this all in one line, but I'm doing it in 3. Return S3. So right now I'm doing exactly what I said not to do. Oops. Okay? I'm concatenating strings in this function with the plus. Hello, let's just do like 1, 2, 3. These are the strings 1, 2, 3, 4. So what does this code say? Crisscross concatenation. It says, okay, 1, 2, 3, 4. Concatenate 1 and 3, start in S1, then 2 and 4, and then concatenate those two together. So we should have 1, 3, 1, 3, 2, 4. then we return it. Okay? Yeah? Happy, sad? Run. 1, 3, 2, 4. Good. Right? Why? Well, A becomes 1, 2, 3, 4. And then if you just look at the order, A is 1, C is 3. So we have 1, 3 stored in S1. And then 2, 4 stored in S3, S2, or sorry, 2, 4 stored in S2. So we have 1, 3, 2, 4. Concatenate it, we get 1, 3, 2, 4. Right? Now I said you're not allowed to use plus. So how can we do this? Well, here's how. We're not allowed to use plus, but if you read, we are allowed to use this function. And what does that function do? Well, it's first, A plus, like, string 1 plus string 2 returns the concatenation of those two strings. But you're not allowed to use the plus. Concatenate strings, string 1, string 2, returns the concatenation of those strings. So we can do the concatenation of strings without the plus, but I can do it like this. Oops, AB, no, AC. B, D, and then one more, S1, S2. And it still works. So this function calls another function, and we can do that forever. Now, time for a quick activity. All right? So grab your pieces of paper. Remember, you're allowed to work together and whatnot. I want you to do, to do this activity right here. Right? Write that function on paper and hand it in to me no later than 12:20. If that turns 12:21, I'm not taking it. You're going to hand it in here, and remember, no handing in anybody else's or anything, lest we have problems.